Right, hello, welcome to another revision lesson. This time we're going to have a look at nth term of a linear sequence. As usual, have a piece of paper and a pen or pencil ready so you can do some work as we go. Right, some knowledge retrieval of the basics. Read the question, pick an answer, pause the video if you need to, and then you can resume the video and check if you've got the question right. Okay, on this question here, we're asked for the third term of the sequence. 3 is the first term, 7 is the second term, so 11 is the third term. Next one, pause it and have a go. Right, this time we're asked for the next term in the sequence. This is a sequence that is going up by 4 every time. So if we continue that pattern and add 4 to 15, we get that 19 is the next term in the sequence. Next one. Right, once again, the question's asking for the next term. This is a descending sequence. The sequence is going down by 7 every time. So to find the next term, we subtract 7 from -4, gets us C, -11. Next question, the missing term in the arithmetic sequence. So all the sequences we've seen so far have been arithmetic. That means they go up or down by the same amount every time. So if the gap between these two is +7, then the gap between the second and the third term will also be +7. 15 plus 7 gives us 22. This time we're asked for the difference between the terms in the sequence. So if we have a look at the first two terms, to get from 5 to 9, we need to add 4. We can double check that, the third term and the fourth term as well. We've got a difference of 4. So A was correct. This is a substitution question. We're asked to work out the value of this expression when n is equal to 5. It means we need to replace that n with a 5. We need to remember that 2n means 2 multiplied by n. Therefore, when we swap the n for a 5, we end up doing 2 times 5 plus 3, which is 13. Another substitution, this time we're placing the n with a 10. We do -2 times 10, take away 4. -2 times 10 is -20. Subtract 4 from that, you get -24. Okay, first 5 terms of an arithmetic sequence, find an expression for the nth term of the sequence. The nth term is the formula that describes the sequence. We begin by finding the difference between the terms, which is 5. So the first part of our formula will be 5n. Now, 5n describes the 5 times table, which is not our sequence. Our sequence goes up in 5s, so it's like the 5 times table, but it's not. What we need to do is we need to compare our sequence with 5n and see how it's different. And if you compare the first terms, and then you compare the second terms, and then you compare the third terms, you should see that our sequence is 2 more than the corresponding term of the 5 times table. So our nth term is 5n plus 2. You try that one in exactly the same way. So you should have noticed you've got a difference of 4, leading you to the 4 times table. And when you compare our sequence against the 4 times table, you should notice that our sequence is 4 more. 4n plus 4. Okay, another one. This time a descending sequence or decreasing sequence. To get to the next term, we are taking away 3. That means our sequence is like the -3 times table. If we compare our sequence against the -3 times table, we'll see that our sequence is 15 more. So -3n plus 15 is the nth term. You try that one. So we've got another descending sequence. The sequence is going down in 2s, meaning it's like the -2 times table. If we compare our sequence against the -2 times table, we should see that our sequence is 22 more, leading to -2n plus 22 as our nth term. There's some questions for you to try. Pause the video, have a go at them, and then resume the video and see the answers. And there are the answers. Mark your work. And finally, we'll finish off with a few exam questions. So, find an expression in terms of n for the number of counters in pattern number n. Pause the video and have a go at this. Okay, so if we take our pattern numbers and just simply count up how many dots there are, we turn it into just a simple nth term question using a sequence. Sequence goes up in threes, so therefore the first part of the rule is 3n. 4 is 1 more than 3, 7 is 1 more than 6, and so on. So therefore 3n plus 1. Part B. Can Bayo make a pattern in the sequence using all 90 of his counters? So we're working out, is 90 in this sequence 3n plus 1? If it is, we'll be able to solve this equation. We'll get an integer value, and that'll tell us what pattern number it is. Now, if we try to solve this equation by subtracting 1 from both sides, we'll get 3n equals 89. Now, you should recognize that 89 does not divide by 3, because 90 would. 90 divided by 3 is 30, but if you take away 1, you're not in the 3 times table anymore. So n is equal to 89 over 3 is not an integer. Therefore, 90 is not a number in this sequence. Right, another one for you to try. Pause the video and have a go at this. Right, part A, again, nth term of the sequence. Difference is 6. Compare our sequence to the 6 times table. We see our sequence is 1 more, so 6n plus 1. Part B, different sequence this time, same process as the last question. Is negative 58 a term in this sequence? Well, if it is, we'll be able to solve this equation and get an integer solution. Start by taking away 8 from both sides, and you get negative 6n is equal to negative 66. Divide both sides by the negative 6, and you get 11. So yes, it is a term of this sequence. It's the 11th term of the sequence. And there's one more for you to try. Pause the video, try this one. Right, this time the question asks for the next 2 terms of the sequence. We can see the sequence is going down in 5s every time, so therefore the next 2 terms will be 20 and 15. A term of this sequence is negative 5. Which term? We could just continue the sequence and then go through and count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's the 11th term of the sequence. And finally, an nth term is given by that expression. Find the 9th term of this sequence. In this question, we need to take the value 9, substitute it into the expression, replace the n for a 9. 4 times 9 is 36, plus the 3 is 39. The 9th term of the sequence is 39. Right, and finally, if you need more practice, here's 3 different Sparks Maths tasks you can have a look at in the independent learning section.